Hello, Hornets. In this video, we are continuing with curve sketching. This time, we're going to be taking a look at a very basic rational function. You'll notice in this rational function, so you've seen this in your pre-calculus. You might have seen it in your Algebra 2 class. We're going to start with our basics. We know that our numerator gives us the zeros. And we know it comes from the denominator that we find asymptotes. And according to what we've worked on this year, as well as what you saw last year, the horizontal asymptotes are going to come from the ratio of leading coefficients. So from this, we're going to start by finding our zero. Our zero is x equals 0. This will then identify our y-intercept is also 0. So we have 0, 0. We have an asymptote. Let's label it as the horizontal. And this horizontal is going to be at y equals 2. And asymptote vertical is going to be x equals negative 2. We're going to take note that as we do our first derivative, I am working with the quotient rule, low d high less high d low, square the bottom, and away I go. And I end up getting 2 times x plus 2 divided by, let's go to the top, times 2x times 1 over our denominator x plus 2, the quantity squared. And then this will simplify into 4 over x plus 2, the quantity squared. Our second derivative is now going to work with this function, and I'm going to rewrite it to something that's a little bit easier to work with, and find my second derivative is negative 8 over x plus 2, the quantity cubed. Alrighty, now it's from the second and first derivative that's going to give us concavity, points of inflection, and whatever else we might find, increasing, decreasing, relative maximums, relative minimums. So I'm going to make a sign chart with this. You'll notice that my sign chart has only one value on it. That value is our only critical value, and the only critical value we have is where the function is undefined. Notice the function is undefined at x equals negative 2. Again, that's from our first derivative. And you'll notice that we have a positive 4. And we have 1 over x plus 2 and 1 over x plus 2. We have a positive, positive, as 4 does not change. We have a positive and a negative, positive and a negative. And lo and behold, my function is increasing over all intervals. So let's just write that down. F of x is increasing. We have to be careful because this is an asymptote. So we're going from negative infinity to negative 2 and from negative 2 to positive infinity. Keep in mind that once we have an asymptote, we always have an asymptote. Let's look at this one. Negative 2 is still our asymptote. We're now working with concavity. Negative 8. I have 3 of these fractions, 1 over x plus 2, 1 over x plus 2, 1 over x plus 2. We now have a negative for negative 8, but a positive and a negative, positive and a negative, positive and a negative for a positive negative. Now, this is telling me that f is concave up on negative infinity to negative 2, and f is concave down and this is happening on negative 2 to positive infinity. And we're going to want to now put all of this together into our sketch of our curve. So I'm going to start off with my two asymptotes. I have an asymptote at negative 2. This is my x equals negative 2. I have a positive 2. That's giving me my horizontal asymptote. Y equals a positive 2. Now you'll notice I'm going down 2 and over 2, which means that I'm going 4 and up. Notice over and down, 0, 0. Concave down over the entire interval. Here's 0, 0. Now we have this point, negative 4, 4, and it is the mirrored image of that point. And our curve approaches the vertical asymptotes. And here is our sketch. This is the curve that we're looking for. Notice we have our concavity. There is no point of inflection. There's no point of inflection because of the asymptote. Okay? There is no 0 here to change in sign. Here we have f is increasing on. Here we have all of our asymptotes and information. And we're done with our graph. So please keep in mind, curve sketching requires us to utilize all of our information. Next, we'll be taking a look at a complex rational function. Thank you very much, Hornets. Be well and be safe, and we will see you all again soon. Thank you. Bye-bye.